systems of equations. And there's many ways to go about that, but we're going to focus on doing it graphically today, or visually. So what is a solution to a system anyways? It's just a certain x and y value that will satisfy both equations at the same time. Or another way to think about it is when you plug in that certain x and y value, which is the solution, the left-hand side and the right-hand sides of the two equations would equal each other. So here I've graphed out, or I've tried to graph out the two equations that we have here, and we know that these are linear because they're both to the first degree, or the first power. And they just happen to intersect at the point -2, 8, which happens to be in the second quadrant. And let's go ahead and plug in this x value of -2 and the y value of 8 into both of these equations to see if the left-hand side and the right-hand side would equal each other. So when I plug in the -2 into this first equation here, into the x value, I get -4. And when I plug in 8 into the y there, 8 times 3 is 24. And we want to see if that will equal 20. So 24 minus 4 does equal 20. So this checks off. Now let's go ahead and try the second equation here. 2x, so 2 times -2 would be -4 plus, now I'm plugging in 8 for the y, and I want to see if that equals 4. So -4 plus 8 does equal 4. So that's what I meant by when I said when you plug in that certain x and y value into both equations, that the left-hand side and the right-hand side will equal each other. So let's go ahead and try some more examples graphically or visually to get a better understanding. Okay, after we looked at that little introduction, let's go ahead and try an example of solving linear systems graphically. So here we have a purple line and the pink line. We don't know what the equations of these lines are, but the concept is just to see what the solution to the system is graphically. So we know that they intersect right here at this point, which happens to have an x value of 4 and a y value of 2. So this is a fairly straightforward example. We could conclude that the solution to this system would be 4, 2, because this point lies on both of these lines, which means it would satisfy both lines, and that's pretty much it for this example. Okay, so here's another example. I want you guys to give this a try. So I have the equations listed there, but we're really not focused on that. We're here to see the solution visually or graphically. So here's the blue line and the red line. So why don't you guys just try to identify what the solution is graphically, and then we'll go over it together. So assuming that you gave that a shot, also assuming that everything is scaled by 1, this intersection point looks like we moved over once in the x direction and went down once in the y direction. So it looks like that point right there is 1, -1 is over 1 and went down 1, so it's -1. So just looking at this visually, it looks like the solution to this system equation happens to be 1, -1. Okay, so the two examples that we tried previously were fairly straightforward. The intersection points were very easy to visualize, but that doesn't always happen to be the case. So here we have two functions again, linear functions, one in red, one in blue, and we could distinguish the intersection points right there in the fourth quadrant, but it doesn't really happen to be at a perfect point. So if we're talking about the x-axis, if we trace this back, looks like it's about there, right? So it's in between 1 and 2, but it's leaning more towards the 2. So to me, that x value looks like 1.8. Again, if you see a different value, that's fine, we're just approximating. And the y value, if I trace this back, -0.8. So if I were to write the solution as an ordered pair, x and y coordinates, the x value that I approximated was 1.8, and the y value looked like -0.8. And again, that's just the way that I saw it. You might be seeing it differently, but just keep that in the back of your mind that we don't always get nice solutions out of these linear systems. Okay, so let's go ahead and look at this example here. We have a line here drawn in blue and another line drawn in red. And I just want to point out that these lines are parallel, meaning that they have the same slope. So let's go ahead and look at the multiple choice and see if we can narrow it down to one answer. And I suggest you guys go ahead and maybe pause the video and just briefly look over the multiple choice before I go over it. So let's see what choice A says. Yes, there's always a solution to linear systems of equations. That actually turns out to be false, because there's only a solution if the two lines intersect each other. We don't see any intersection throughout this region, or doesn't look like they're going to intersect in the long run. So part A would be false. Let's look at B. No, the lines do not intersect each other. B could be a potential answer because I don't see any intersection happening between these points, and since they are parallel and they have the same slope, seems like they're never going to intersect each other. So B could be a potential answer. So moving on, C, it says yes, the lines will eventually intersect each other. That would be true if the lines were in parallel, because eventually they would intersect each other at some point. But since we said in the beginning of the problem that these lines are parallel, that's not going to happen. So C would also be false. Now let's look at D. No, because the lines are parallel. D is also correct because the lines aren't going to intersect each other because they're parallel, so hence there would be no solution. So let's look at E. E is saying both B and D. We said B could be a potential answer, and D is the right answer, and they kind of work off each other. So narrowing it down, let's just look at F2, both A and C, but we said A and C were false, so the only answer we're left with is E for this multiple choice. So this was just really to bring up the concept that when you're trying to get the solution of a linear system graphically, just first look out for the case where the lines are parallel, because you're not going to have a solution in that case. Okay, so why don't we have you guys try an example? We're just trying to see what the solution to the linear system is by looking at it visually, just seeing if there's an intersection point and where that occurs. So why don't you guys go ahead and give this a shot before we go over it together. So if we start at the origin at 0, don't move anything in the x direction and move down 4 units in the y direction. So 1, 2, 3, 4. And the lines do intersect at that point, so the correct answer would be E. Okay, so let's go ahead and look at this problem. Still focusing on the concept of seeing the solution of a linear system visually through a graph. So here we have a yellow cab versus a blue cab, but it looks green to me, so I don't know why they're calling it blue. But anyway, so this yellow line represents the cost of the yellow cab, and this blue or green line represents the cost of this blue cab. And the question's asking us, after how many miles will the cost of both companies be the same? So since they're asking about the miles, I would put my focus here on the x-axis, which is representing the number of miles. So why don't you guys go ahead and give this a shot, and we'll go over it together. So let's go ahead and look through the multiple choice. I'm going to start backwards. I'm going to start with E. So E's saying never. So it's saying that these lines never intersect each other at a point, right? Because the cost is going to be the same after a certain mile, right? So I do see an intersection here. So part E is just vague because I do see an intersection point, so I know the cost will be the same at one point. So never would apply to a case that was a parallel line example like we did previously. But these lines do intersect at a point, so I could disregard E. D says 4 miles, so if I look down here 4 miles and I trace up, I don't see an intersection there. It's very close to an intersection point, but at 4 miles they don't really have the same cost. So moving on to C, at 0 miles, again, I see different costs here. The yellow cab's cost is 2, and the green or blue cab is 5, so different cost still. Moving on to B, after 3 miles, I see that that's the one. I know it's off a little bit, but it's after 3 miles, they both have the same cost. So I don't have to look at part A. We concluded that the answer is part B, because after 3 miles, they would both have the same cost.